All right, hi everyone. Okay, we are going to work with simple harmonic motion, which is the most recent topic that you've had. Number 15, they give the displacement is 0 at t equals 0, which is telling me this is going to be a sine All right. Okay, so we are dealing with at 0, t equals 0. You're dealing with, looks like a sine function to me. And the standard, d equals sine omega t. And d equals a times sine omega t. And A is, amplitude is 10 centimeters. Sine, now omega, the period is two pi over omega. A period is 6 seconds. So we got to just figure out what that coefficient of t is for the omega. So 2 pi over omega is equal to 6. And if I just kind of multiply both sides by omega, get those I got 2 pi is equal to 6 omega. Divide by 6. That's pi over 3. So I'm going to put pi over 3t for my answer on that one. Now on 17, the displacement is 6 inches. So it's up here. It's 6 inches. So that looks like cosine at t equals 0. So I'm going to write d equals a cosine omega t. And figure out what omega is with a period of 4.5 seconds. So that's still 2 pi over omega. And that's 4.5 seconds. And 4.5 W is equal to 2 pi. Let's go over 4.5 and 4.5 here. And omega there, 2 over 4.5, 2 pi over 4.5. I'm going to make it look a little nicer. Let's multiply top and bottom by 2, because that'll make that 9. So that's 4 pi over 9. Sorry for the sloppiness there. So my formula, the model that we'll have here, is the amplitude, 6 inches times cosine of 4 pi over 9t. Right there. All right. Now this last one, they give us the model and the maximum displacement. So from equilibrium would be 2/3 of whatever units. I'll just put units because that wasn't specified here. The frequency is the reciprocal. Frequency, it's a reciprocal of the period. So how long does it take to go through a cycle? And that would be omega over 2 pi. So omega here is 6 pi over 2 pi. And those pi's cancel out, and that's 3. And that's a frequency is a length, and I'm going to guess that this is in seconds. So, and I see seconds down here. I just didn't see any units up here in the model. So 3 seconds there. What is the value of d when t equals 6? So we just take 2/3 times the cosine of 6 pi times 6, which is 2/3 times the cosine of 36 pi. Now, 36 pi, its coterminal angle, I think you'll find, you go around by 2 pi. The coterminal angle is 2 pi. So the cosine of 2 pi is 1. So this is just 2/3 times 1, which is 2/3 of a unit, whatever the units are. All right, the least positive value of t when d equals 0. If we were to draw this, there's one period. Okay. Now the period is equal to 2 pi, oops, I got turned around there, 2 pi over omega, which is 2 pi over 6 pi, which is 1/3. This is 1/3. That's 1/3 of a second. Half of that is 1/6 of a second. Half of that is 1/12 of a second. And that's our answer. This is the first time, the least positive value of t when d is 0. 1/12 would be the smallest value. Now this is 1/12, 2/12, 3/12. This is 1/4 would be another one. But the least is 1/12 is smaller than 1/4. So this is 1/12 of a second. That's how long, the first time to get to equilibrium from the start is 1/12 of a second. Now, this is cosine. When cosine is 0, you're at pi over 2. This is 0, 1, right? When cosine is 0, pi over 2. So I think Mr. Shell was showing you the alternative way. I'm showing you just by looking at the graph and labeling this, the t-axis here. But you can do this 6 pi t when it is equal to pi over 2. And you divide by 6 pi, divide this by 6 pi, that's pi over 2 times 1 over 6 pi. You'll see your pi's will cancel. 2 times 6 is 12. So that's another way of getting 1/12. And this was more along the way that Mr. Shell showed you. Okay. Now, let's do some of these navigation problems here. A ship leaves port at 4 a.m., the bearing south 30 degrees east. So I'm going to put the ship right here and kind of draw my compass south 30 degrees east. So I'm going to go right here, and that's 30 degrees that way. Sails, the ship sails at 15 knots. 15 knots, that's nautical miles per hour. And we left at 4 a.m. How many nautical miles south and how many nautical miles east will the ship have traveled by 11 a.m.? So we're talking 7 hours times 15 nautical miles per hour. 70 and 35, that's 105 nautical miles. So this is 105 nautical miles here, from here to here. All right, we need to figure out this value. This is the east value, and this value is the south value. And it looks to me like we can take opposite over hypotenuse, because this is a 90-degree angle here. We can use some SOHCAHTOA. And opposite over hypotenuse is sine. So the sine of 30 degrees is equal to the east value over 105. And if I multiply both sides by 105, I am going to get the calculator out for that. Although sine of 30 is 1/2, I do know that much. 105 times 1/2 is 52.5 east. So east is 52.5 nautical miles. Get my calculator for the next part. Okay. And then south. That is adjacent to the 30-degree angle over hypotenuse, so that's cosine. So the cosine of 30 degrees is equal to the south measurement times 100 over 105. So I'm going to multiply by 105 on both sides. And the south, okay, I'm going to check my mode real quick. I am in degree mode. So I'm going to take 105 times the cosine of 30 degrees. I'm getting 90.9. So south is 90.9 nautical miles. Okay. Just gonna, at 11 a.m. the ship changes course to due east. Find the ship's bearing and distance at noon. Okay. So I'm going to, we're going to say that's from the original starting place. I'm going to draw this. And we had the 30 degrees here, and then the ship, and that's 105 nautical miles. The ship goes due east for 1 hour. 1 hour. That's, and we already know that this here is 52.5, and we know this is 90.9. And then for 1 hour, how fast are we going here? 15 nautical miles. 15, from here to here is 15. And then, so we'll kind of draw this. Okay. This is 105. I want to try to find this. And what I could do is, I'm going to redraw this a little bit. I know that's 90.9. This is 52.5. This is 30 degrees. Let's go 15 nautical miles there, and let's connect that there. I put 0.5, that's 90.9, that's 52.5. Okay. And that's 52 and 0.5 and 15, that is a total of 67.5 nautical miles. All right. I can figure out this right here. I can also figure out this angle. I'm going to make that my theta. I'm going to go opposite over adjacent. So the tangent of theta is opposite, 67.5 nautical miles over 90.9 nautical miles. Okay, and that's approximately 0.7426. Theta is going to be the inverse tangent of 0.7426. In other words, I'm kind of taking the inverse tangent of both sides here. And the inverse tangent of tangent, that's just theta. Those cancel each other out. So I'm going to take the second tangent, inverse tangent of 0.7426, and I get 36.6 degrees. Inverse trig function gives me the degrees. So that's 36.6 degrees. So I know that, and I might just use Pythagorean Theorem to get the distance. Make that C. So 90.9 squared plus 67.5 squared is equal to C squared. 90.9 squared plus 67.5 squared is 12,819.06. I'm going to take the square root of 12,819.06. I get 113.2. C is approximately 113.2 degrees. All right, so let's write down the bearing. Right. It is south 36.6 degrees east, and the distance is right there. Okay, that's not degrees, that's what threw me off here. Nautical miles is 113.2 nautical miles. Okay, there we go. Number 19. Number 20. An airplane is 220 miles north and 150 miles east of an airport. So let's draw our airport right here. We'll go 220 miles north and 100 miles east. And this is the plane. So here's the airport, here's the airplane. The pilot wants to fly directly to the airport. They want to go directly here. This is 220, this is 100. What bearing should the pilot take? Well, I think what I'd like to find, I kind of need to do this. What I'd like to find is, I think this angle right here is where I'm going to go for. Theta, opposite over adjacent. So the tangent of theta is 220 over 100. Theta is the inverse tangent of that. So the inverse tangent of 220 over 100 is 65.6 degrees. I'll put approximately 65.6 degrees. All right. So we got to figure out what this angle is. This is 90. This is 65.6. So if I take my 360 degrees, which would take me all the way around, and I subtract the 90 degrees that's right here, and then I subtract the 65.6 degrees right there, I get 204.4. And the bearing for a pilot, all you need to say is 204.4 degrees. And he or she will know that that is the direction they need to go. Okay. And last but not least, number 21 here. A sailboat leaves a pier heading due west. Here's my sailboat. Here's due west at 8 knots after 12 minutes. Okay, this is 12 minutes here. Knots is nautical miles per hour. 12 minutes, that is 12/60th of an hour. And I think if you do the math there, you'll find that's 0.2 hours. And since this is nautical miles per hour, I'm changing this to 0.2 hours here. The sailboat changes course at 10 knots. Okay. After 12 minutes, the sailboat changes course at 10 knots. Okay. Find the sailboat's bearing and distance from the pier 15 minutes on this course. Okay. Now, so 8 nautical miles per hour for 0.2 hours. Times 0.2 hours, that's a decimal, is 1.6 nautical miles, just 1.6 nautical miles. Okay, so that's due west, 1.6 nautical miles. Changes course and goes 10 knots for 15 minutes after it changes course to north 19 degrees west. So let's go 19 degrees here. And 15 minutes, 15/60ths, that is 0.25 hours. So a fourth of an hour is 15 minutes, 0.25. And 10 nautical miles per hour times 0.25 hours is 2.5 nautical miles. So this is 2.5 nautical miles right there. So, find the sailboat's bearing and distance from the pier, from right here, 15 minutes on this new course here. Okay. Here is our bearing, or here's our distance right here. Okay, I'm going to take a second. I'm just going to get another piece of paper. I'm getting all right, let's just redraw this one right here. I just need more room than what I'm giving myself here. So this is the pier. The boat goes 1.6 nautical miles first, and then it goes 19 degrees west, so then it goes like this direction here, and this is 19 degrees right here west of north, and this distance here is 2.5 nautical miles. So what we really need to find here is this distance, which it would really help if we kind of complete this right triangle here, right here. Now this is 19 degrees here, which would make this complementary, or we actually could just put the 19 degrees here. These are opposite, what do you call it, opposite? Parallel, when a transversal cuts parallel lines, these two angles are congruent, and I forget the name of it. Mr. Madigan will be mad at me. But these two angles are the same. Or we could say this is a 71 degree angle. I'm just going to stick with this 19 degree angle here. Figure out this so that I can make my right triangle, and then we'll worry about this angle here in a minute. But let's just get these sides here first. This is 2.5. This is 19 degrees. This is the opposite side. So we're just kind of going a little bit west here and a little bit north here. So let's figure out what that W is. That little W is not to be confused with omega, right? That little W is the west from the turning point on the sailboat. And we need to take opposite over hypotenuse. So that is the sine of the 19 degree angle, is W over 2.5. And I'm going to multiply both sides by 2.5. And let's figure what that is real quick. 2.5 times sine of 19 degrees is 0.814. So that's 0.814. And then adjacent, so let's use cosine. 19 degrees is the north bearing over 2.5, the hypotenuse. Multiply by 2.5 there, and 2.5 there, and 2.5 times cosine of 19, that's 2.364. This is 2.364 nautical miles. I'm going to add 1.6 plus 0.814 together and get 2.414. This is 2.414. Nautical miles. And I'm going to put theta here. I want to figure out that angle. Opposite over adjacent. So the tangent of theta is the opposite, 2.364, over the adjacent, 2.414. So theta is the inverse tangent of 2.364 over 2.414. Okay, which is approximately 44.4 degrees. So theta, this is 44.4 degrees. Now we need to measure from the north. I'm going to take 90 minus 44.4, and that's 45.6 degrees. So we are north 45.6 degrees west for our bearing. Now the distance. I need to find this. I may as well just use Pythagorean Theorem again. Although I could use, let's use SOHCAHTOA. Let me go off of the 44.4 degrees. That's opposite and that's adjacent. So the tangent of, I'll call this D, of 44.4 degrees is the opposite side, 2.364, over the adjacent side, 2.414. Okay. Yeah, I already knew that. I want D, that's a hypotenuse. So let me take the opposite over hypotenuse. Let's take the sine of 44.4 degrees, and that is the 2.364 over the hypotenuse, which I'm calling D. Sorry about that. I'm going to multiply both sides by D. That cancels. And then I'm going to divide by the sine of 44.4 degrees on both sides. So D is equal to 2.364 divided by the sine of 44.4 degrees, 3.379 nautical miles. So bearing north 45.6 degrees west, and the distance is 3.379 nautical miles. All right, guys, there we are.